Absolute values with compound signs are just a little bit different. An inequality means that there's more than one answer. So what we have to determine is when is this or is this ever going to be greater than or equal to -9? When I take any number that's inside an absolute value, so for example, the absolute value of 4 is 4, it's a distance from 4. The absolute value of -3 is +3 because it's a distance. So in this case, whenever you take the absolute value of something, you get a positive number. And is a positive number greater than or equal to -9? In the case is a positive number can never be bigger than a negative number. So in this case, there's no solution. Let me give you another example. So here's another example. The absolute value of x plus 1 is greater than or equal to 5. So I'm going to show you how to do this algebraically and also how to do this somewhat logically. I can test values. I can say, well, suppose x equals 5. If I plug in a 5 here, 5 plus 1, is that greater than or equal to 5? Is the absolute value greater than or equal to 5? Yes, so 5 is a solution. What if I said x equals -10? -10 plus 1, the absolute value of -9, is that greater than or equal to 5? Well, that's 9 is greater than or equal to 5, so here's also an answer. I could do, 5.1, 5.2, 5.3, and so on. So algebraically, how we solve a problem like this, they can be negative numbers, they can be positive numbers. So we take what's in the absolute value, x plus 1, set it greater than or equal to 5, and I'm going to turn this into a compound inequality. I also want to know the numbers on the other side. The arrows always point in the same direction, and the opposite sign. So now whatever I do to the middle, so I'm going to subtract 1, I do it to both outsides. So I have -6 greater than or equal to x greater than or equal to 4. So these are all the values. And I could graph them out for you. Here's 0, 1, 2, 3, 4. Closed circle going in this direction. 1, 2, 3, 4, 5, 6. Closed circle going in the opposite direction. So any values in this shaded area or this shaded area, if we plugged it into the original problem, it will work.